which will be focusing on the pile analysis. Or it says that more focusing on how are you going to analyze the ultimate bearing capacity for a single pile and as well as for the pile group. Okay, just to refresh back what you have learned last Friday, it was about the pile classification and how do we decide it when we're going to use a deep foundation instead of the shallow foundations. So as you remember, in terms of the design and constructions, we can classify we can classify pile into two types. The first one, we call it as a driven or displacement piles, which are usually preformed before being driven, dragged, screw or hammer into ground. So kalau you ingat balik last Friday, so the speaker also talk about how the pile drive in, and then what would the method of installations selain daripada driven, kemudian kita ada jack in, kemudian kita ada replacement. So the second one is on board or replacement piles, which require a hole to be first bored into which the pile is then formed, usually of reinforced concrete. So, kalau kata kita nak classify pile selain daripada dia punya functions and also the method of installations, we can also classify pile into the material and also its functions. Kalau you tengok last Friday also the speaker gave some example untuk driven pile. Contohnya you ada apa what we call it concrete pile, kemudian kita ada span pile, kemudian kita ada H steel pile. So banyak lagi lah jenis-jenis pile. And then kalau kata bore pile, contohnya kita ada board cast in situ. So itu antara contoh-contoh perbezaan antara driven pile dan juga bore pile. Okay, in terms of the bearing capacity, load carrying capacity of the pile, so kita boleh classify pile juga kepada end bearing pile ataupun skin friction pile, atau the pile has combination between end bearing dan juga skin frictions. So yang tu pun I will not explain further, but I think that all of you can understand how to differentiate the pile functions on end bearing as well as the skin frictions. Mana kata kalau kata kita nak tengok the bearing capacity of the pile, we can look at the end bearing at the bottom of the pile itself, ataupun kita boleh tengok perimeter the perimeter of the pile length. Kat situ pun dia akan bagi skin resistance. So when you have the skin resistance, so they can create the skin frictions untuk bagi the bearing of the what we call here the capacity of the pile itself. So now I am going to explain further on part of the analysis is on the what we call it here is an analysis lah. Maknanya macam mana kita nak kira ultimate bearing capacity through the static formula. Okay, yang ni ikutkan dia adalah sebahagian daripada topik 2 dan kita pun dah bincang minggu lepas. So yang ni lebih kepada refresh balik what are the end bearing and also the skin frictions. So kalau ikutkan the ultimate bearing capacity of the single pile can have from the skin capacity QS, which is calculated from the F times AS is a skin shaft area. Kemudian F is a unit frictional resistance, while the QP is the end bearing and also can be calculated from the formula QP times AP, the area of the point ataupun the area of the base of the pile. So the D here is referring to the embedded length. Macam kalau you tengok minggu lepas punya talk, the pile length it depends on the strength of the soil. So berapa banyak kedalaman yang kita perlu tanamkan pile tu, so bergantung kepada jenis tanah. Somehow let's say you have a pile length is a 10 meter. Tak semestinya 10 meter tu kita akan embed dalam tanah. Boleh jadi 8 meter sahaja daripada 10 meter. So the D is referring to embedded length. Berapa kedalaman pile yang tertanam. So the area of the pile at the end ataupun the bottom of the pile depends on the cross sectional area. Macam saya bagi tahu last tadi, ada pie yang bentuk cross sectional dia adalah rectangular, ada yang bentuk square, ada yang bentuk hollow, ada yang bentuk circular. So the area of the point at the end of the pie bottom ni, kita kena tengoklah cross sectional area dia. Sama ada you menggunakan square pile ataupun you menggunakan circular pile. And then similarly for the shaft area. Shaft area, kalau you ada circular pile, so the formula will be different, as well as kalau you ada bentuk 4 segi. So kalau you ada bentuk pile 4 segi, so kita boleh kira shaft area adalah 4 darab dengan dia punya length lah. Berapa dia punya ukur lilit keliling pile tersebut. Okay, ini adalah definitions on the friction pile, kemudian on the end bearing pile. So yang ni I will not further discuss today because last Friday pun the speaker has explained to you, as well as the load applies to piles. Kita ada loads from in vertical directions, horizontal directions, kemudian kita ada moment acting to the piles. So pile applications can be differ according to the functions. Ada pile yang kita letak dekat offshore yang kita panggil sebagai tension pile ataupun breaking piles. Ada pile yang kita guna untuk piers, ada yang kita guna untuk high-rise building ataupun any other superstructure. Okay. Now back to our business today is on calculations pile analysis. So the ultimate bearing capacity of the pile QU is summation to the QB plus dengan QS. And the weight of the pile can be assumed as a 0. Maknanya W ni adalah weight of pile tolak dengan weight of soil displaced. Berapa yang kita excavate untuk letak pile tersebut. But somehow it is ignored except for the steel pile. Okay. This is similar as what I explained just now. To calculate the factor of safety is a similar what we have learned from shallow foundation, yang mana QA kita panggil sebagai allowable pile capacity is the summation of the skin capacity QS plus dengan base capacity QB over dengan factor of safety. Atau ada cara lain, dia split out antara QB bahagi dengan FB plus dengan QS bahagi dengan FS. So kita akan ambil whichever smaller factor of safety. Okay, ni adalah summary kepada what we going to learn pile in cohesive soil. Okay, pile kalau kita nak analyse, we can have into two major groups of soil, yang mana kita boleh look at to the granular dan juga fine granular, which is coarse soil, dan juga fine soil, contohnya silt dan juga clay, atau kita panggil sebagai cohesive dan juga cohesionless soil. For cohesive soil, piles in cohesive soil, it can be calculated from a few methods. For example, by using the alpha methods. So the alpha methods is only applicable kalau you are analysing for pile capacity in the total stress analysis. Yang mana when I mention as a total stress analysis, it means that you can look at to the strength parameters of the soil. So it also known as a short-term analysis, and this is only applicable in the clay only. So apa dia punya difference ataupun significance between alpha method, beta method dan juga lambda methods? You may see after this. How are we going to calculate accordingly through the conditions of the stability of the piles dan juga formula yang terpakai. Contoh, kalau kita nak look at to the alpha method, yang mana F ni adalah skin resistant, F clay is equal to alpha darab dengan C. Kalau untuk clay ataupun cohesive soil, kita tak panggil sebagai skin, kita panggil dia sebagai addition factor. So the F is a unit addition or skin frictions, while C is a coefficient of undisturbed clay, and alpha is a factor that relates addition to cohesion. So you may see after this, macam mana dia ada kaitan antara alpha dan C. It means that you are given the C value. From there, you have to determine the alpha ataupun addition factor. So then the ultimate bearing capacity of the part is only differ at the second term. Kalau tadi saya bagi tahu ultimate bearing capacity of the single part QU consists of QB plus dengan QS. So dalam kes ni, kalau you tengok perbandingan semua antara tiga method in cohesive soil ni, setiap method alpha ke, beta ke, lambda ke, dia hanya berbeza pada QS saja. So you akan nampak lah, macam contohnya alpha method ni, dia punya QS consists of alpha times dengan average undrained CU times dengan shaft surface area within a given layer of UD strength CU. Okay, untuk base capacity QB, you can have the formula is a CU and CAB. Okay, CU selalunya kita akan rujuklah base file kita tu berada dekat which layer of soil for that particular undrained strength, undrained cohesion. So kalau kata base kita tu berada pada layer yang ketiga dengan nilai undrained cohesion is 20 kPa, so kita akan guna 20 kPa dalam calculation for QB. How about the NC? So NC ni dia bergantung ya. Kalau ada some example clay yang jenis intact clay, so kita akan pakai NC 9.0. Meanwhile, for fused clay, kita akan pakai NC is a 6.75. It also recommended that for addition factor, usually we can take the value of 0.45 ataupun 0.34 over consolidated clay. Okay, itu adalah alpha method. Meanwhile, for beta method, which is more applicable for effective strength analysis, it also known as a short ataupun long-term analysis for all types of the soil, as can be seen in here. Ini dekat QS ni dia berbeza lah. You akan nampak kat sini. QS dia adalah beta method. Okay. Beta is comprises K tangent delta. Itu adalah beta sebenarnya. So kalau kita nak katakan beta tu adalah K tangent delta. That is the beta. So this one, they expanded the equations yang mana K average overburden pressure tangent delta times dengan AS. So the F ataupun addition factor, F is not the addition factor. F is represent to the unit additions of the resistance of the skin for the pile itself. So comprises antara beta times dengan average overburden pressure. So the QB masih lagi sama sebagai CU and C darab dengan AB. The only difference dekat QS dia. So masih lagi sama. Beta is addition factor usually taken between 0.25 to 0.40. And then what is the K naught? K naught is the earth pressure coefficient. So some calculations dia ada bagi formula lah macam mana nak kira K naught. Contohnya K naught sama dengan 1 minus sin phi. Itu formula lah untuk kita kira K naught. Ataupun kadang-kadang dalam soalan dia terus bagi K naught. So you just substitute in the equation, so you akan dapat what we call it here as a addition unit factor F. Okay, untuk kaedah yang seterusnya iaitu lambda method. Okay, the lambda method ni, if you look at to this one, so the addition factor usually taken between 0.5 to 0.117. So it depend on the mean and mean shear strength, which the concept assuming that internal friction angle is equal to 0. Ataupun arti kata lain kita consider this sebagai total strength analysis lah dengan purely cohesive soil. So these are three methods to calculate ultimate bearing capacity of single pile in cohesive soil. Okay, the next one, you may see that what we call it here, the expanded explanations, what we had in this method to calculate the pile's capacity. Contohnya, macam saya bagi tahu lah, there are some factors considered in the analysis and how the additions around a pile can be part of the factor and then factor calculations in the end of the results. So it is common to assume the undrained condition exists at the time of loading, but recent studies have shown that the dissipation of excess pore pressure takes place fairly quickly. By the time the pile is fully loaded, the condition may be near to being drained. So that's why it says that dalam cohesive soil ni, dia ada condition total stress, dia ada condition untuk effective stress. Yang mana stability ni, whether you look at the short-term stability analysis ataupun you look at to the long-term stability analysis. Okay, yang ni pun benda yang sama macam saya explain tadi. Okay, this is how are we going to determine the addition factor according to the alpha method. Okay, the variations of alpha using the undrained coefficient. For example here, this is the upper bound limit and this is the lower bound limit. So we're going to take the alpha at the average coefficient Cu. For example here, kalau kata you ada undrained coefficient 150, so kita akan ambil pada nilai average and then kita akan tarik lah untuk dapatkan nilai alpha dia. So this is the estimated alpha. Okay, somehow it also recommended the values for alpha kalau undrained coefficient U less than 25 kPa, and then if you have the undrained coefficient within the range 25 to 75, this is how you can have the alpha ataupun addition factor unit, and as well as kalau you under undrained coefficient more than 75 kPa. Okay, ini adalah beta method. Ini pun I have explained just now. Okay, dalam beta method ni, it depends on the soil type lah. This is what I explained just now. Kalau you nak calculate the K naught. The K naught, it depends on the K naught is actually the lateral earth pressure coefficient at rest. So, it can be calculated from this formula. Kalau you ada normal consolidated clay, so kita just take it 1 minus sign effective internal friction angle phi. Kalau you ada over consolidated clay, this is how we calculated the K naught. Okay, what is the effective VR? It is referring as a drain friction angle of remodeled clay. So yang ni you have to go through from the textbook. How are we going to analyze accordingly for different type of the clay, sama ada NC ataupun OC. Yang ni pun kaedah lambda. Okay, yang ni kaedah lambda yang mana you akan nampak lah macam mana kita nak calculate dia punya average Cu dan juga average effective stresses. So dia bergantung kepada multi-layered lah ataupun your pile embedded in the multi-layers of soil ataupun in the single layer of soil. So you can see the differences between three methods here from alpha, beta dan juga lambda. So the next one, we go to the static analysis on the cohesionless soil. So the cohesionless soil, kalau you tengok tadi, it's just like similar to the clay for the beta method. Sebab apa? Sebab tadi dekat fine soil, kita dah jumpa dah beta method kan. So the beta method is actually comprises antara K, S, tangent delta times dengan average overburden stress times dengan AS. The QB, QS, QB masih lagi benda yang sama. QS ni, kat sini kita akan fokus on the beta method. Okay, yang ni adalah dia punya terminology, nominations, apa yang kita ada. Okay, one thing not to forget, since we are considering pulse in cohesionless soil, you can see what we call it here, major differences between pile in clay dan juga pile in sand at the QB. Pada end bearing capacity, kalau kata kita ada sand, kat sini dia adalah NQ. So kita akan guna NQ. This is I mean. So ini adalah perbezaan dia. Somehow bila you ada clay, dia bukan NQ, dia adalah NC. So itu yang you kena kena apa? Kena fokus lebih lah. So you have to analyse kalau your problem is on single pile in single clay, so kita pakai NC. Kalau you ada single pile in single sand, so kita akan pakai NQ. Okay, NQ ni dia boleh diperolehi from this relationship lah between the angle of shearing resistance internal friction free, juga ratio to the L to B and also NQ. Kita nak dapatkan nilai NQ kan? So wait a second sir. Okay, this is one example how we going to determine, estimate NQ for having ratio L over B as well as the angle of shearing resistance. So kalau you nampak just now in clay lah, for example, if you have a normal consolidated clay ataupun over consolidated clay and somehow assuming that the phi is a 0 for undrained conditions in the total stress, you might see that the phi or the angle of shearing resistance is equal to 0. That's why untuk you calculate end bearing capacity QB, kita akan pakai CNCAB. Tapi dia berbezalah untuk pile in sand yang mana kita akan pakai sebagai NQ. Even though the formula also different because right now kita dah tak ada dah C dekat bahagian depan untuk end bearing. Sebab sekarang ni dia adalah sand. So replacing dengan overburden pressure times dengan NQ times dengan AB. So overburden pressure kat sini ni kita nak calculate ambil kat mana? So kita akan ambil effective overburden pressure at the pile 2. So ini yang you have to make differences ataupun differentiate between pile in clay dan juga pile in sand. Okay, not to forget also, dalam this case untuk sand, kita ada delta iaitu angle of friction between the pile and the soil. Later I show you, okay, this is what it says that the skin friction coefficients depending to the type of piles dan juga types of pile construction, sama ada driven or bore pile. And then for this particular example, if you have a concrete pile driven ataupun embed bored in the loose sand or dense sands, it says that the KS is around 1.0 to 2.0, while the delta can be estimated from this formula 0.75 times dengan internal friction angle phi. Okay, bila you dah dapat that one delta, so kita akan estimate the beta S accordingly to this type of the phi lah. Kalau you ada phi 25 darjah, so kita akan pakai this round. Depends on pile you duduk kat mana, loose sand ke ataupun dense sand. Kalau kata piles you bukan jenis konkret tapi dia adalah steel pile, so you have to look at this bottom table lah. Okay, the data also depending to the pile material lah. Yang ni macam tadi juga dia explain, but different references lah. Tadi satu daripada this kind of book, satu lagi from this reference from 1966. So this is some suggestion how to get the data value on steel pile, concrete pile dan juga timber pile. Okay, this is one example. Kalau you want to calculate the bearing capacity of the pile in clay, so I will not further explain detail for each example. Saya hanya pergi mana yang penting lah, because as you remember, some topics may not consume 2 hours online lecture lah, sebab as I said, the remaining hour for you to have your learning activities. Maknanya through the learning activities, you can have discussions, you can do your activity. From that, that's the learning by self ataupun by student-centered. How you get in balik apa yang dah belajar from the online class, kemudian you apply, you adopted the methods, technique or concept just doing the activity to have the full understanding on the topic itself. Okay, I just give you one example for each pile in clay ataupun pile in sand. This is one example where we can have a pile diameter of the 400 millimeter and the length of pile is 6 meter to be installed into a deep deposit of clay. So all our informations are very important for you to understand what exactly the method we're going to use, especially in the particular soil. Okay, the clay has an undrained shear strength of 180 kPa at the depth of 6 meter. An average undrained shear strength of 100 kPa over the depth 0 to 6 meter. So it mentioned that the average undrained shear strength of 120 kPa for length 0 ataupun for depth 0 to 6. So it means that the CU average has already given in 120 kPa. The formula that you got in the earlier lecture just now showed to you that the CU kita kena ambil sebagai CU average. And somehow these questions, dia dah bagi you nilai CU average. So it doesn't has any more problems. We just can direct calculate lah. Okay, the pile is circular. So to calculate the QB and bearing capacity, you just take it the CB times dengan NC times dengan AB. NC pun dia dah bagi 9. Addition factor pun dia dah bagi sebagai 0.6. So just substitute balik. Contohnya kat sini CB 180, NC 9. Sebabkan kita ada circular pile, so pi d square over 4. So the end bearing is a 203.5 kPa. Okay, untuk skin bearing capacity, so alpha darab dengan average CU times dengan AS. So you can see that here, untuk kita calculate AS, the shaft pile, so it is as a pi DL. So kita akan calculate dia 3.142 darab dengan D darab dengan L. Okay, this is the formula untuk dapatkan the cross-sectional shaft pile. So lepas ni you jangan confuse lah. Tapi dia berbeza bergantung kepada bentuk pile. Kalau kata ASU, pile U adalah circular, so this formula is applied. Maknanya 3.142 pi darab dengan D darab L. Tapi kalau kata U ada square pile, so this formula is not applicable anymore. Sebab apa? Sebab pile kita sekarang bukan lagi bentuk bulat. Pile kita bentuk 4 segi. So kalau you tengok 4 segi ni, in order to calculate dia punya shaft perimeter ataupun cross sectional perimeter of the shaft, so kita just take it 4 darab dengan length ataupun diameter ataupun the size for each the size side of the pile itself. So kita akan dapatlah dia punya AS. So addition factor 0.6, average CU is 120. So finally kita akan ada skin frictions 542.6. So kita total up untuk dapatkan bearing capacity of single pile is a 746.1 kPa. So nampak macam mudah kan, tapi sebenarnya kalau you tak faham, dia sebenarnya boleh bagi you wrong answer lah.
Okay, this is more complex yang mana dia menggunakan grain analysis and also in the multi-layers of soil. So you can see that it's combined between granular dan juga clay yang mana two upper parts of the soil layer sand ataupun pile in sand. Kemudian the third layer from the ground surface piles in clay. So you can see that how it is being calculated untuk dapatkan what I mean here the average CU lah. So dia berbeza according the formula will be different according to the pile in sand ataupun pile in clay. So I think that this one you have to go through by yourself lah. But I want to concentrate is that contohlah kan dekat sand ni sebabkan kita ada multi layers, so you have to be careful lah. Sebab apa? Bila kita nak calculate dia punya QS lah, especially lah QS. QB dia tak ada masalah sebab QB dia kita just ambil the end bearing. Contohnya kat sini lah Okay, CB darab dengan ini untuk clay kan. Kalau kata QB untuk sand, kita just ambil overburden stress darab dengan NQ darab dengan AB. Okay, tapi untuk QS ni sebabkan dekat sini dia dipanggil sebagai overburden pressure, average overburden pressure. So the average overburden pressure ni kita akan ambil at the center of the soil layer. So kita tak akan ambil as full depth. Contohnya macam ni kan. Kalau kita tengok granular field ni, dia punya kedalaman dia adalah 3. Sebab dia bermula daripada 0 meter sehingga 3 meter, pile duduk dalam loose granular field. Tapi bila kita nak calculate dia punya QS, the average overburden pressure at this first layer, kita tak ambil sepenuhnya sebagai 3 meter tau. Kita akan ambil dia sebagai, kita akan calculate overburden pressure at the mid layer of the granular field. So how to calculate dia punya overburden pressure? So 20 darab dengan 3 bahagi dengan 2. Itu yang dimaksudkan sebagai average lah. 20 ni apa dia? 20 ni adalah kat sini kita panggil sebagai 1. Okay, gamma 20 ni adalah unit weight of the soil. Gamma ni dia punya Z tu adalah 3. 3 kenapa bahagi 2? Sebab kita nak ambil the mid ataupun center of the soil layer. That's why kita bahagi dengan 2. Okay, tangent 0.75 darab dengan 30 ni semua datang daripada soalan ni. Kemudian kalau kata kita nak sebabkan pile ni adalah satu single pile. Tapi dia tertanam dalam 3 jenis tanah yang berbeza. First layer is the granular field, second layer is the dense gravel and then the third layer is the clay. So kita nak estimate ultimate bearing capacity of the pile sehinggalah at the bottom pada kedalaman 8 dan juga 11 meter. So kalau you nak calculate, okay, this part kenapa kita tak ambil end bearing capacity dia daripada sand formula QB from sand? Sebab bottom pile kita ni berada dalam clay, dia bukan berada dalam sand ataupun pada penghujung pile ni, pada penghujung cerocok ni, dia berada in clay zone. It's not located or positioned in the gravel ataupun field. That's why kat sini we only have QS from field as well as the gravel. But somehow in clay kita akan ada QS from clay dan juga QS from B. QS from clay, QB from clay. Sebab penghujung pile ni berada pada clay. Dia tertanam dalam clay lah, dia bukan tertanam dalam sand dan juga gravel field. So now bila you look at to the gravel the second layer of the soil here, dia masih lagi sama. Kita nak calculate overburden pressure average. So kita akan ambil pada center of the depth. So tadi 0 hingga 3, kemudian 3 ke 7. So 3 ke 7 kan. So macam mana kita nak calculate the overburden pressure, the average overburden pressure? So we're going to take overburden pressure from the first layer as a full. Maknanya 20 darab dengan 3, kita akan dapat overburden pressure campur dengan overburden pressure from the second layer but in the middle, dekat bahagian tengah ataupun dekat bahagian center of the part. So kita takkan ambil penuh sebagai 4 meter kedalaman gravel. So what we're going to do that is 21, 60 ni daripada upper layer granular field tambah dengan unit weight in the second layer 21 darab dengan depth is a 4 meter bahagi dengan 2. Bahagi dengan 2 sebab kita nak estimate at the center ataupun at the middle of the gravel layer. So that's why I hope that you can understand lah kenapa dekat field just take it like this. Kemudian bila pergi ke second layer dia ambil pula macam ni. Okay, kalau yang clay for the third layer, of course lah dia berbeza kan, formula dia berbeza sebab sekarang ni dia dah pakai untuk clay formula dengan dia pertimbangkan average CU. Kenapa kat sini kena ambil average CU? Sebab you akan nampak at the upper part pada kedalaman 8 meter, kita akan ada dua nilai CU. Satu nilai CU pada 7 iaitu 120 kPa. Lepas tu kita ada nilai CU pada 8 meter 145 kPa. So takkan kita nak ambil orang kata apa? So which value that we're going to calculate or we're going to use in the formula? CU mana nak pakai ni kan? Sebab bila kita tengok 7 kPa, 7 meter kita ada satu CU. Lepas tu 8 meter kita ada satu CU. So the simplest way tak nak merumitkan keadaan, kita just averagekan dua nilai CU pada 7 meter kedalaman dan juga 8 meter kedalaman. So bila kata average, bagi dua lah nilai yang kita ada. Kalau kata pal tu tertanam pada ada lagi kedalaman yang berbeza dengan nilai CU yang berbeza, so kita akan tambahkan bagi kepada 3. That's the idea, the solution for this example. Okay, finally, what we want to estimate is the ultimate bearing capacity kan. So yang ni saya just explain pada 8 meter lah. Untuk 11 meter ni you tengok semula. So finally, the end bearing ni kita calculate daripada 8 meter iaitu 256.2 in clay. So tambah dengan from field, kemudian from gravel, kemudian from clay. So you nampak lah kenapa dekat sini QS ada 3 components. 58.6 campur 632.1 campur dengan 124.9. So you total up, you akan dapat the ultimate bearing capacity for single pipe is 1071.8 kilonewton. Yang ni benda yang sama, cumanya sekarang ni dia extend to the ultimate bearing capacity lah dan juga allowable bearing capacity. So you are asking kira kata the back calculations lah, given that factor of safety is 2. Kemudian you have to estimate the Q allowable. From the Q allowable you akan dapat Q ultimate, and from the Q ultimate you have to estimate the last one lah, contohnya the QS dan juga QB. So you can take this example for further study lah. This is just now I explain mana yang kita ambil sebagai average CU to determine the addition factor alpha. Yang ni yang dia minta dalam soalan tadi, Q design ataupun Q allowable. Okay, there's a lot of examples for this topic. I mean that kalau you look at closely and take your time to read through all these examples, you may understand the differences calculations on pile circular, kemudian pile square. Okay, this is example kalau kita ada square pile, yang mana tadi I mentioned to you that the formula is the formula untuk dapatkan AS adalah 4 darab dengan cross sectional area of the pile. Kalau kata cross sectional area kita tu bentuk square, so kita akan darab B darab dengan L. So kita ada berapa side? 4 kan? 1, 2, 3, 4. So 4 darab dengan B darab dengan L. So kita akan ada one example here untuk pile skin shaft for contact area square pile dimensions. So this is what we're going to have. So it is totally different pile in circular. Kalau kata you ada circular shaft, formula dia tak boleh lagi pakai macam ni lah. So have to be careful bila you want to solve the analysis for different type of the pile. Okay, the next one we go to the negative skin frictions. Negative skin frictions ni is a condition yang mana bila you have the value of shaft resistance develop between the pile and the soil in a downward directions and result in the increase of the load on the pile. So apa yang berlaku? The piles are driven through a layer of film material which slowly compacts or consolidate due to the Un's weight. Kemudian, the layers underlying the file consolidates under the weight of the film. So negative skin frictions, look at to this one, you can see that how it is mentioned to you, the created ataupun the forming of the negative skin frictions. So bila kita penetrate pile, selalunya bila kita move downward, so dia akan ada skin frictions in opposite directions tau. Tapi bila benda ni berlaku ataupun negative skin frictions berlaku, dia tak bagi you upward punya direction, skin frictions upward. Tapi dia bagi you the skin frictions, the contact between pile and soil in downward directions. So that's the conditions yang mana it has formed the negative skin frictions. So negative skin friction, they can give you some impacts lah. This, how it is explained here just now. Okay, dalam negative skin frictions juga, the load carrying capacity of the part subjected to negative skin friction is calculated as you can see here. So kita ada sekarang ni QB times dengan AB plus dengan summation QS ASR. QS ni adalah negative skin frictions. QS. Okay, the next one is on the settlement dan juga pile group. Tadi kita just now I explain on the single pile capacity. So now how to estimate the bearing capacity of the pile group. So bila talking about the pile group, last talk the speaker also mentioned to you that macam mana kita nak combine few single pile in a group. Maknanya kita akan pakai pile cap. So dalam pile cap ni, kat situ kita akan susun lah pile kita sama ada dalam 3 orientations ke ataupun dalam bentuk 4 orientations. So the pile cap tu depend to the pile arrangements lah, the number of pile. So the number of pile also can give to you the efficiency of the pile group. So how to calculate the efficiency of the pile group ni, dia bergantung kepada ultimate group load dan juga ultimate individual load. So contohnya, kalau you ada pile group in sand dengan efficiency more than 1, but actually kita hanya ambil efficiency dia sama dengan 1 lah. Tapi kalau bore pile in sand dengan efficiency dia adalah 0.6, so this is due to the shear zone develop. So the idea on the efficiency of the pile group need to be calculated from the individual pile. Contohnya, kalau tadi kan kita ambil satu contoh lah. The ultimate bearing capacity of the single pile just now is equal to, let's say we have 1071.8 kilonewton. Ini untuk single pile. Kalau kata kita ada 4 pile, maknanya 1078 tu kita akan multiply dengan 4. So macam mana kita nak tahu dia punya efisiensi? We have to calculate first the ultimate group load. Ataupun dia can give you in reverse way. Contohnya apa? Efisiensi kita dah tahu sama dengan 1. Contohlah. Macam mana kita nak tahu dia punya ultimate group load? Efisiensi darab dengan number of pile darab dengan ultimate individual load. For example, just now, what is the ultimate bearing capacity of the group load for 4 piles? So, you can calculate it dengan cara efisiensi tadi 0.6 darab dengan 4 darab dengan 1078 kN. So you can have the ultimate group load. So dia vice versa lah, sama ada you are asking to determine efficiency number ataupun you are asking to determine ultimate group load capacity. Okay, dalam gambar ni you can see that is actually bila kita nak apa kata nak design pie cap lah kan, dia bergantung kepada spacing of the pie itself antara satu pie sehingga pie yang berikutnya in one row ataupun in few columns. So how it is arranged according to this kind of concept lah. Makna kata kita kena kirakan, kita kena kira spacing antara setiap pie. So pie ni bukan kata kita main letak je. Kalau kata kita ada 3 pie, so macam mana kita nak susun 3 pie tu? So we have to estimate the spacing dulu. Lepas tu kita kena determine dia punya length LG dan juga width BG. So baru kita boleh dapatkan the right dimension of the pie cap. So in that manner ataupun in that things, the pie cap is depending to the ultimate bearing capacity of the pie group. So the pie group, the bearing capacity of the pie group can be estimated from this one, NC darab dengan undrained CU BG LG plus dengan average CU 2D times dengan BG plus dengan LG. So the NC is the Scampton values from the table ataupun figure. CU is the undrained shear strength at the depth T. BG is the breadth of the group block. LG is the length of the group block. D is the depth to the base of group. And average CU is the average undrained shear strength between 0 and D meter below the surface. So if the pie cap rests on the ground, the design load should be taken as the least of the ultimate group load and the sum of the individual pie capacity QU times dengan N. When the pies are freestanding, the design load should not exceed 2 over 3 QUN. So dia ada conditions lah, ada setengah pie dia akan meet to the hard rock ataupun hard layer, hard stratum. Ada setengah pie dia tak jumpa hard layer, so dia akan stand freely kat situ. So in a way to design, to estimate, and this is the idea, it shows that how to design the pie cap. Sebenarnya dalam you punya syllabus ni, dia hanya cover sehingga estimate the pie group capacity saja. Dia tak extend to the pie cap designs lah. So you are quite lucky just to know how to estimate the ultimate bearing capacity of the pie group. Okay, in the last few topics before this one, saya pun ada explain to you kan, kalau kata kita nak estimate settlement untuk shallow foundation, kita boleh calculate through the immediate ataupun elastic settlement, primary settlement ataupun secondary settlement. So settlement ni sama ada you nak analyse untuk shallow ke deep foundation ke, dia punya formula sama sebab dia datang daripada konsep settlement. So dia tak ada beza. Any topics, application, settlement for shallow ke, settlement for deep foundations ke, kita menggunakan the same formula here. So dia boleh calculate from this formula pertama ataupun dia can be calculated from the second formula. Dia bergantung kepada informations lah, apa parameter yang diberikan pada awak. So kalau kata you are given the coefficients of volume compressibility, so kita akan pakai MV. Tapi kalau kata you tak ada pun these informations on the MV, tapi you ada initial void ratio, so we can estimate the settlement from the first formula. Okay, sebenarnya settlement ni, it tries to give you the idea, the stress distributions at the bottom of the pile. Kalau kata kita ada pie group, kemudian this is the length in the depth 2/3 of the L, and the remaining of the pie is the L over 3. So we assuming that the stress distributions in the block zone. So macam mana kita nak calculate dia punya nilai this one? So we need to consider the settlement at the center of the clay. Main kita tak ambil settlement pada full H lah. We're going to take ataupun estimate settlement at the center ataupun half of the H. Okay, the detailed explanations on this part you can see from here. Okay, piles are usually placed in groups with center-to-center spacing, typically between 2 and 5 shaft diameters. So the ratio of the average load in pile group to the ultimate single pile load is referred to as efficiency of the group. Okay, yeah, and then the efficiency is a ratio between ultimate group load over the total number of pile times dengan ultimate individual pile. So this is how it says that in a way to decide the pile arrangement, dia bergantung kepada the spacing for each pile. Berapa jarak antara satu pile ni kepada satu pile yang lain. So ini some arrangement recommendation kalau you ada 2 by 2 piles in square arrangement ataupun you ada 5 number of piles in circular arrangement. So it mentioned that bila kita nak susun dia, just imagine as the stress distribution logically lah kan. Kalau kita ada 5 pile, takkanlah pile ni kita susun keliling dia. So to be fair or uniformly distributed of the stress, so kita akan apply one pile dekat center. Okay, macam mana kalau you ada 7 piles pula kan, kita nak letak dalam satu group. So you have to logically arrange so that the pile can carry the loads. Okay, just now dalam this one dia fokus, yang ni dia fokus pile in cohesive soil. Tapi sebenarnya pile pun dia boleh juga berada dalam cohesionless lah. But the cohesionless bergantung kepada relative density lah. For example when piles are driven into sand, the relative density will increase and thus the group bearing capacity may be greater than the sum of the individual capacities. However, for the design purposes, the efficiency is taken as 1.0. In the case of ball pile in sand, the efficiency is lower because the shear zone of adjacent piles overlap, giving the values of efficiency as low as 0.6. So ini dia punya set requirement kalau you nak calculate pile group in the sand through the driven method ataupun from the board method. Okay, kemudian pile group in clay. Pile group in clay ni dia dah bagi specific formula how to estimate, and then assuming that the stress distribution in the failure block zone. Maknanya tadi you akan nampak mana yang kita panggil sebagai block zone. This is what it says that dengan failure zone in the block conditions is part of the estimated the settlement. Kita akan ambil at the mid center of the clay pada kedalaman D embedded length of the part itself, and then we estimate the bearing capacity of the pile group as well as the efficiency number. Okay, dalam this part the first of all you have to estimate the pile individual single pile dulu, kemudian you akan dapatkan pile group ultimate bearing capacity through this formula. Kemudian you nak dapatkan dia punya efficiency, we can have from the equations lah. Kalau this kind pile group in clays, for example NCU BGLG plus dengan CU 2D times BGLG. So the same explanations mentioned just now. The only part is that BGLG ni adalah number of pile in B or L directions of the spacing plus dengan the pile diameter. So itu yang dia bagi some idea lah macam mana nilai BG tu sama dengan 3 meter ke ataupun sama dengan 2.5 meter. Okay, yang ni yang it says that kalau you kira daripada center to center of the pile, yang tu kita panggil spacing of the pile. Tapi kalau you nak kira LG dengan BG ni, so kita kena ambil daripada what we call it here just now, from kalau kita tengok okay, from the number of pile ni, pucu dia kat sini ataupun from this center length to this center length plus dengan the side of the radius pile at this bottom dan juga pada upper part of the pile. So kita akan dapat nilai LG. L ni adalah the length dalam panjang dia lah. Ni adalah lebar dia. Okay, one example here, as you can see from this question, a pile group consists of 4 friction piles in cohesive soil. So the diameter of each pile is 0.5 meter and center to center spacing is 2.5 meter. NC is 7.0. Design capacity of the group pile, ultimate of the group pile QUT, kemudian QUT for each pile, and then calculate Q equivalent. So the spacing is 2.5, LG sama dengan 3. Ataupun length of the spacing part. Okay, the total length is 3.5 meter. The total B also 3.5 meter. So 2.5. Okay, so given that here is LG is 3. So BG also 3. So the pile group in the clay. So you have to estimate individual and the pile group capacity. So the alpha is a 0.6, and then the pile individual, the ultimate bearing capacity of the single pile is 1,100 kilonewton. So kita masuk je balik formula CU NCAB plus dengan alpha CUAS. Yang ni pile ni dia berada dalam single clay lah. So it doesn't more problem for you to estimate the QU. Okay, untuk calculate ultimate bearing capacity of the group pile, the diameter, the D embankment depth is 20 meter, NC is 7.0. So macam mana dia boleh dapat BG sama dengan 3.0 meter? So this is how it says that. The S is spacing between pile is 2.5, campur dengan the B node is 0.5. So B node ni dia dapat dari mana? Daripada sinilah 3.5 tolak dengan 3. So dapatlah 0.5. So 2.5 campur dengan 0.5 dapat 3.0. Sama juga untuk LG. This one supposedly LG lah. Ini sepatutnya L. So LG pun kita dapat 3.0. So the average CU is 40 kilonewton. And then the ultimate bearing capacity of the pile group is 2D times dengan BG plus LGCU plus CUNC BG and LG. So you substitute into the formula. So finally, what we can have is that the pile group bearing capacity is 14,640 kilonewton. From there, you can estimate the efficiency of the pile group. So the efficiency of the pile group is equal to 3.33. How do we get that one? First, just now kita dah calculate kan ultimate bearing capacity of the group pile is 14,640 bahagi dengan number of pile is 4. Individual pile is 1,100 kPa. So finally kita akan dapat 3.33. So the next question, estimate what is the Q naught. So the Q naught is equal to ultimate bearing capacity bahagi dengan area of the pile group. So the QU is stand here to the pilot of the group pile. So 14,640 bahagi dengan area of the pile group is 3 darab 3. Area of the pile group ni dia dapat balik daripada dimension tadi tu lah. L berapa, L berapa, B berapa. So kita dapatlah 3 darab dengan 3. So to calculate Q equivalent by this question is 2 darab dengan D bahagi dengan 3. So the Q naught from this graph from these figures is equal to 13.33 meter. Maknanya dia punya value kedalaman lah untuk this depth that mentioned to the length of this stress. Maknanya kita nak dapatkan the stress below the pile group here. The Q naught is 13.33 meter. Okay, the next thing, if you want to calculate further on part of the what is here. Okay, tadi kita dah dapat dia punya Q note kan. Kemudian kita nak estimate for each particular Q1. Kalau tengok this table lah. Q note kita dah kira. Kemudian kita nak dapat QEQ kat sini ataupun QE. So we can have from this formula ataupun from these solutions. So this is I leave it to you to have own study as well as the final questions here. Similarly for that example untuk ultimate dan juga allowable. Okay, last but not least for the settlement of the pile group. Settlement of the pile group is actually covered just now from the example where it mentions that the settlement of the pile group in both cohesionless and cohesive soils will be greater than that due to an individual pile. So in order to estimate the settlement, it is usually to consider an equivalent rough located at a depth of 2/3 D where D is the embedded depth of the pile. So what I have shown just now, it is part of the settlement calculations lah yang mana kita nak estimate daripada 2/3 kedalaman pie yang tertanam tu berapa agaknya dia punya mendapat ataupun settlement yang berlaku disebabkan oleh pile group tadi. So the thing is that it mentioned also the angle of the ratio between of the settlement distributions too. The area of the equivalent rough is determined by assuming that the load spread from the underside of the pie cap in the ratio of 1 horizontal to 2 vertical or whatever it is given. So the settlement is then calculated by conventional means. So that's why I said just now, the soalan tadi tu sebenarnya dia dah cover dah untuk kita kira settlement. Kalau kata settlement dalam 2/3 kedalaman tu berapa dia punya effect. And the thing is that bila kita calculate settlement, kita akan ambil the middle ataupun the center layer of the clay. Okay, you boleh calculate through the consolidation settlement punya formula lah. Kalau tengok sini kan, the vertical, the changes ataupun the increment in vertical stress can be calculated from this formula. So sebenarnya dia ada kaitan juga dengan soil mekanik punya topik lah yang mana kita nak dapatkan data sigma V ni. How are we going to calculate that one? So, data sigma V ni, as I said just now, it mentioned to the what we have in the soil question punya parameter lah. Kalau kata soalan tu bagi awak some example yang mana you are given the MV value, kemudian H2 you dah tahu. The thing is that yang you tak tahu tu adalah data sigma V. So the data sigma V ni can be estimated from this formula. So the increase in vertical stress at the depth Z, center of the clay layer is given by here. So itu cara lain lah macam mana kita nak dapatkan data sigma V dengan pertimbangkan the pie group effect. Okay, other than that, so other than that, this is where it also can be estimated from the consolidation settlement ataupun primary consolidation settlement yang mana you are given the initial thickness of the clay and then you have the initial void ratio and then you have the initial overburden stress and then you have the pre-consolidation stress. So dalam this example, lastly ni, you can see that how it is estimated untuk dapatkan Q equivalent sehinggalah untuk you estimate the settlement before and after loading. So dalam kes ni dia bagi you one example yang mana the delta sigma V ataupun perubahan stresses tu can be seen from the loading you apply before and after the changes itself. So the changes itself is significant coming from the pilot from the group of the pile yang mana QEQ ni lah, QEQ yang kita estimated from here. Okay, so read through all this example. Give your time to read on this part. As I said, dalam kita punya final exam, so there's a possibility this topic, subtopic 2, deep foundation will be asked in the final exam. So I'm not sure lah sama ada dia masuk juga dalam quiz ke tidak, tapi you have to understand on these sections all in this in the deep foundation subtopic. Okay, do you have any questions before we end our lecture today? Okay, kalau you ada textbook with lu contohnya basic soil mechanic kan, you can go through from the page 496 sehinggalah to the last topic of chapter foundations ni, you akan pergi ke sehingga page 500 something lah. Dalam 504 to 505 ni, there are a lot of example from the shallow foundation until to the deep foundations. How you can adopt balik dia punya solutions ataupun example to estimate, to calculate the exercises given in the textbook. If I'm not mistaken also from the U Future pun ada nota, ada soalan dalam learning activities yang you can follow through. The only thing that I am not covered here from estimations of ultimate pile bearing capacity from the SPT ataupun from the site data. From the site data ni kita boleh rely on the SPTM values ataupun from the CPT values. So yang tu saya tak cover, but they can be found from the page 498 in the textbook. So again, please look at to these methods. Macam mana kita nak estimate pile bearing capacity from the site data. But my concern is that you need to know how to calculate ataupun analyze from the static equation. Static equation tu yang tadilah saya bagi tahu QU, QB sama dengan QS. QB tu apa benda kalau clay, QB untuk sand tu macam mana, QS ni ada berapa kaedah dia. Itu yang lebih penting lah. Selain daripada settlement for single and group pile. Settlement in pile groups ni dia much more complicated lah sebab kalau you tengok tadi kan settlement in clay pun they can have a failure block zone. So bila kata failure block zone ni you need to estimate berapa nilai Q equivalent tu kan untuk kita dapatkan dia punya overburden stress, the changes in overburden stress. So the last example here or the last question here may help you to give some idea how exactly ataupun how we're going to estimate settlement from the pile group. So pile group ni kalau you understand truly sebenarnya dia mudah lah sebab dia just kita ada single pile. Kalau kata single pile dia punya capacity dia, keupayaan dia untuk carrying the load is 1000. So kalau kata dalam satu pile group you ada 4 pile, so you multiply by 4 lah kan. So that's the easiest way. And then that's how we estimate secara roughly lah tanpa pertimbangkan dia punya what we call it here as a BG dan juga LG. Tapi kalau you go details the ultimate bearing capacity of the pile group in clay, so we need to consider also the effect of the BG dan juga LG tu. So any questions before we end our lecture today? Do you have any questions?
No, madam. So far,
okay.
Okay. For the first one, macam saya bagi tahu dan juga speaker bagi tahu, ada makna kata apa, sebelum kita nak buat keputusan on part of the pile ke shallow foundations ke kita nak guna, so you kena look at to the depth. Tengok dulu kedalaman, tengok dulu soil profile data, and then tengok juga load capacity, load carrying capacity. Kalau kata load carrying capacity is too high, Q design is too big, terlalu tinggi untuk you cater the load, the shallow is not best solution. So we go to the deep foundations. And then when you are decided on the deep foundation menggunakan pile, you have to estimate pula, are you going to use single pile ataupun you are going to use pile group. Kemudian pile tu pula you nak construct dekat mana? Dekat sand ke, dekat clay. Kemudian what method of installation. So these are the things ataupun factors yang you kena pertimbangkan bila you dah buat keputusan berkaitan dengan deep foundation. That my concern is that orang kata apa, you buat analysis, you kena tahu kenapa. Justification, judgment, why you are choosing this method, why you are using this kind of the pile material. Kenapa you tak guna concrete pile instead of steel pile? Dia mesti ada alasan kan. So, itu kira kata pile you tu kita tak pergi secara detail macam mana kita nak design in terms of the pile strength. Kita just nak tahu capacity yang tanggung oleh tanah. Itu je sebenarnya. So kalau you can understand on that part, the estimations of the ultimate bearing capacity of the pile group, single pile, there will be no problem for you lah untuk buat analysis dia. Okay, thank you, and I think that this will be my last sessions with you because next week you akan masuk topik 3 iaitu slope stability sebelum special leave on the 30th of May. So I hope that kalau kata ada something that you want to ask regarding the topic, you can contact me. So saya minta maaf kalau ada terkurang ataupun adalah part-part yang mana ni kan. So saya harap kita jumpa lagi lah di masa akan datang. Okay, Assalamualaikum.
Assalamualaikum, madam.
Terima kasih, madam.
Thank you, Dr.
Thank you, Madam.